Alright, so we're going to start a new lesson in our unit on systems and matrices, which is called the determinant and the identity and inverse matrices. So first we're going to start by talking about the determinant. Every square matrix does have a real number that we call its determinant, and the determinant of a matrix, we'll just call it A, can be denoted in two ways. It can be noted as DET, A, for a determinant of A, or we can use what looks like absolute value symbols, but it represents a determinant of a matrix. Now if we have a 2 by 2 matrix, it's called the second order determinant when we find its determinant. And to find the determinant, there's a little rule we can use. If we are given a matrix, we'll call it matrix A. That's 2 by 2 with the elements A, B, C, and D. Then we say that the determinant of A is equal to A times D minus C times B. So let's look at some examples. So let's look at our first example where we've got the determinant negative 4, 3, in fact, correction, we have the matrix negative 4, 3, 5, negative 10, and we want to find the determinant. So to find the determinant, we have to go negative 4 times negative 10 minus 3 times 5. And really the order is not that important, as long as we keep the A and the D together and the C and the B together. So negative 4 times negative 10, that's going to give us 40. And 3 times 5 is going to give us 15. And 40 minus 15 is 25. So the determinant of this matrix is 25. Let's look at example 2. We take negative 6 times negative 2 minus 11 times negative 3. Negative 6 times negative 2 is 12. Minus 11 times negative 3 is negative 33, which means we're going to go 12 plus 33, in which case the determinant of that matrix is 45. Let's look at two more. So in example 3 here, we're going to go 5 times negative 9 minus negative 5 times negative 7. Well, 5 times negative 9, that's going to give us negative 45. Minus negative 5 times negative 7 is 35. Negative 45 minus 35 gives us negative 80. So the determinant of example 3, that matrix is negative 80. With example 4, we're going to go 2 times negative 8 minus 4 times 6. Well, 2 times negative 8 is negative 16. 4 times 6 is 24. Negative 16 minus 24 gives us negative 40. So the determinant of the matrix in example 4 is negative 40. Alright, and then if we have a 3 by 3 matrix, to find the determinant, which we call a third order determinant, we use the following steps. We are going to rewrite the first two columns to the right of the matrix, and then we are going to create some diagonals. And we're going to find the sum of the downward diagonals, and then the sum, in fact the sum of the products of the downward diagonals, and then same with the upward diagonals, and then we subtract them. So let's look at example 5 so we can see what these steps really mean. So when they say rewrite the first two columns to the right of the matrix, they mean just on the outside to the right of the matrix, go and rewrite those first two columns. Then diagonally, we're going to go from left to right and create some diagonals. We should get 3 of them if we have a 3 by 3 matrix. And then we're going to do the same, but this time instead of diagonally from the left, we're going to go diagonally from the right and create those diagonals. Now the downward diagonals are the ones where we moved from left to right. The numbers go down in the matrix. So the downward diagonals, first we're going to find the products of them. We go 3 times 4 times -1, which is going to give us -12. We go -7 times -5 times 1, which is going to give us 35. And then lastly we go 2 times -5 times 5, which gives us -50. And then we add those 3 numbers, and we're going to get -27. The upward diagonals are the ones when we went from right to left. The ones that from right to left, or in fact from left to right, go up the matrix. So we're going to go 1 times 4 times 2, which is going to give us 8. We're going to go 5 times -5 times 3, which gives us -75. And then we're going to go -1 times -5 times -7, which gives us -35. We add all of those together. So 8 minus 75 minus 35, it's going to give us -102. And then we subtract the upward diagonal from the downward diagonal. So we're going to go -27 minus -102. If we do that, we're going to find that our determinant is 82. Correction, we'll get 75. Let's check a couple more of these out. So let's start with example 6. We've got 6, -3, 6, -1, 4, 2, -3, -6, -4. So we start by writing the first 2 columns to the right of our matrix. We're going to go 6, -1, -3, and -3, 4, -6. And now we can go from left to right and make our downward diagonals. And then we can go from the right and make our upward diagonals. So first we find the product, the sum of the products of our downward diagonals. We go 6 times 4 times -4, which gives us -96. We have -3 times 2 times -3, which is going to give us 18. And then 6 times -1 times -6, which is going to give us 36. So if we add all of that, we'll get -42. And then if we do our upward diagonals, we're going to have -3 times 4 times 6, which is -72. We're going to have -6 times 2 times 6, which again is negative 72. And then we're going to have negative 4 times negative 1 times negative 3, which is going to give us negative 12. And if we add all of those, we're going to get 156. Negative 156. So now we're going to take our downward diagonals, sum, negative 42, and we're going to subtract from that our upward diagonal sum, negative 156. When we do that, we're going to find the determinant of this matrix is 114. Let's check out. So we're going to start by just rewriting the first two columns. And then I like to go in and circle my diagonals. That way I know which numbers I need to multiply. This part's not really required, the circling. The diagonal portion is. The circling, that's just a thing I like to add in. Alright, now we're going to find the products of our downward diagonals. So we have negative 3 times 2 times negative 4, which gives us 24. We have 4 times 5 times negative 3, which gives us negative 60. And we've got negative 7 times 2 times 8, which gives us negative 112. When we add those, we get negative 148. When we do our upward diagonals, we have negative 3 times 2 times negative 7, which gives us 42. We have 8 times 5 times negative 3, which is negative 120. And we've got negative 4 times 2 times 4, which gives us negative 32, which when we add these is going to give us negative 110. So when we go negative 148 minus negative 110, we're going to get their difference to be negative 38. So the determinant of example 7 is negative 38. Let's check out example 8. So again, we start by writing the first two columns to the right of the matrix. And then I like to go and do my little circling for the diagonals. Just let me redo that circle. That one did not look good. And then we do the next one and the next one. And now we can go do our other diagonals. Alright, so first we're going to have negative 8 times 2 times 0. So that's going to be 0. Negative 8 times negative 6 times negative 6 gives us negative 288. And then 5 times 3 times negative 2 is going to give us negative 30. So when we add those up, we're going to get negative 318. Now we can do our other diagonals. We're going to have negative 6 times 2 times 5. So we're going to have negative 60. We're going to have negative 2 times negative 6 times negative 8. which gives us negative 96. And lastly, we're going to have 0 times 3 times negative 8, which is 0. When we add those up, we get negative 156. When we now subtract these, we get negative 318 minus negative 156. So the determinant is going to be negative 162. So to give this an application, we can find the area of a triangle using the determinant. So if we're given the angle, the vertices in a triangle, we call them x1, y1, x2, y2, x3, y3. The area can be found by taking half of the determinant of where x would be a matrix, where each row has the x and y coordinates of the vertices and ends in a 1. So let's look at example 9. So if we have triangle PQR with vertices at P, negative 5, negative 2, Q, 3, 9, and R, 7, negative 4, we want to find the area. So the area is going to be half of the determinant of the matrix negative 5, negative 2, 1, 3, 9, 1, and 7, negative 4, 1. So first, let's find the determinant of A. So let's start by rewriting our matrix. We're going to have negative 5, negative 2, 1, 3, 9, 1, 7, negative 4, 1. And then we're going to rewrite those first two columns to the right of the matrix. Negative 5, negative 3, 7, negative 2, 9, negative 4. And then we're going to find the diagonals. Alright, so we're going to start by calculating these products. We've got negative 5 times 9 times 1. Let me redo that in red. So we're going to get negative 45. We've got negative 2 times 1 times 7. So negative 14. Then we're going to have 1 times negative 3 times negative 4. And we're going to get 12. If we add all of those up, which I did make one mistake, this 3 should actually be positive, meaning 12 is negative. I made that mistake when I was writing those different columns in. When we add all of these, we're going to get negative 71. Then we do our other diagonals. We've got 7 times 9 times 1, which is 63. We have negative 4 times 1 times negative 5, which is 20. And then we have 1 times 3 times negative 2, which is negative 6. So when we add those, we get 77. So we're going to go negative 71 minus 77, and we're going to get negative 148. And then we're going to multiply that by a half so we can find the area. So the area is going to equal negative 74. And we're going to wrap this video up